All right, so here's the 3.2 homework. Again, nothing about the fundamental theorem is changing. The only thing that's changing is that we need to use U substitution to work with it. Excuse me. So, number one, I see a function and a function. I see that function's derivative. I don't see the right coefficient, but we can take care of that. So I pick my U value, take its derivative. I need to account for that coefficient of 6. So I've got my 1/6 on the other side. And then I rewrite my integral. Use my anti-power rule, so add 1 to the exponent, divide by the new exponent, and then substitute the values back in. And from there, I can just do f of b minus f of a. It's up to you if you want to save the 136 for later or distribute it. Feel free to use your calculator to get your final answer. Actually, this might simplify, so double check my answer. Number 2, we're not going to worry about remembering the unit circle, so feel free to use your calculator for this. Just make sure you're in radians. Again, I see a function and a function. I see one trig function, so I know I'm not going to pick that trig function. So I pick my u value, take the derivative, and instead of having to divide, because it's 1/4 dt, I'll multiply both sides by 4. Rewrite my integral. Now this is a transcendental, so I just need to remember that the antiderivative of secant squared is tangent. Substitute back in, do f of b minus f of a, and my final answer is 4. Number 3, again, I see one e value, so I know I should pick its exponent. If you're kind of thinking ahead to what the derivative of 1 over x is, it makes sense that we see x squared in the denominator. So I've picked my u value, rewrite so I can use my anti-power rule, and sure enough, when I take my antiderivative, I end up with x squared in the denominator. I don't have the -1, so I'm going to multiply both sides by -1, and I get my new integral. The antiderivative of e to the u is e to the u. That makes it a little bit clearer. And then I've got f of b minus f of a. Feel free to give the decimal equivalent to this. I just left it in terms of e. All right, number 4, I see two trig functions, so I know I'm going to pick a trig function. I'm going to pick the trig function with the larger exponent, so I'm going to pick cosine. I rewrote my integral to make it easier for when I need to do my anti-power rule. Find my derivative of cosine. I don't have the negative, so I'll put the negative out front. Add 1 to my exponent, divide by the new exponent. Looks like somehow I lost the cosine there. So then I rewrite. Feel free to use your calculator to finish this one, but I've got f of b minus f of a. All right, number 5. Again, like we talked about, if you see a natural log, you pick a natural log. I only see one square root, so I pick what's inside the square root. Seeing that x in the denominator should hopefully look a little familiar for the derivative of natural log. So by the time I rewrite, I've got du over square root u, so I rewrite it as u to the -1/2, so I can use my anti-power rule. Add 1 to the exponent, multiply by the reciprocal. Substitute natural log back in. Feel free again to finish on your calculator, but I've got f of b minus f of a, and that's going to get me 3. Double check that, 4, 2, 4, 2. The answer should be 2, not 3. And finally, number 6, it's hard to tell that we've got this function in the function. It's also hard to tell that we have a function in its derivative since we don't see any other variables anywhere. But when all else fails, pick your denominator. Take the derivative, get a coefficient of 2, which I do not have in the problem, so I divide by 2. Rewrite my integral. 1 over u is natural log, so I've got my antiderivative. I set up f of b minus f of a. And again, feel free to finish this on your calculator. We get about 0.549. All right, hopefully this has helped. If you have any questions, bring them up in class. We've got our quiz on Thursday and then Christmas break. Have a good day.